All right, here's your notes for 3.2. So we've got some inequalities, a polynomial set less than 0, x cubed minus 2x squared minus 3x. And so first off, we're gonna factor this. Ultimately, we're gonna set it equal to y and then kind of graph it. We're gonna make a sine graph. But here we go. Let's first off just factor out an x. So we'll have x times x squared minus 2x minus 3 and is less than 0. Now this part here is going to, this factor will continue factoring down. So we have x times x plus 1 and x minus 3. And actually, let's make this first x a little bit bigger. Is less than 0. And what we're going to do now, so let's get our factors, or our roots rather. We have roots at 0, -1, and 3. And essentially what we're going to be doing is setting this kind of like it's equal to y. We're going to graph it over here and just see where the output, where the y value is greater than 0, where it's less than 0, and kind of go from there. So you'll notice the y-axis is just dotted. It's we're not really concerned about the y-axis so much as just whether or not the output is positive or negative or 0. And we're going to have, as it says here, we're going to factor it. So now we've factored it, we found the roots. And we're going to graph using the zeros and end behavior and possibly some asymptotes. So we'll get to that actually in the next, or in 2 problems from now. But here we go. Let's graph. So we have a 0, kind of at 0, and a 0 at 3. So 1, 2, 3, and at -1. Now, if you look back up to x cubed, so it's an odd function, so the 3rd degree, and our leading coefficient is a positive number. So leading coefficient is positive. That means we are going to start at -infinity and head towards positive infinity. Start at -infinity and heading towards positive infinity. And so all single roots are it's gonna head on up. It's got to turn at some point, come back down, turn again, and head back up. And later when you graph the sine graphs, you're not going to be worried as much about the graph itself, but just getting the information from it. But we'll build towards that. So first off, when x is less than -1, the graph is, the output is negative. So when x is less than -1, we have a negative output. Once we get past -1 and as we get to 0, our output becomes positive though. So from -1 to 0, we have a positive output. And then again, we're at negative numbers again and ending at positive. And we'll break that one up as well. Back to positive. So if we're looking at the output, where does it satisfy the inequality? Well, so our solution is where x is less than -1, and we don't want where the output where y is 0, because we're just looking for where it is less than 0. So it's negative in this region right here and this region right here. So from when x is less than -1, and then again from when x is greater than 0 but is less than 3. So here's our solution, and those are the values that if we were to plug those in for x, that will give us negative values. If we were to plug in numbers between -1 and 0, we'd end up with positive values. So if this instead had said if the polynomial was greater than 0, we'd have solutions kind of like from, and this isn't what it is, but if it had said that it was greater than 0, then we would end up with -1 is less than x, which is less than 0, and then where x is greater than 3. Those would have been solutions for if it was greater than 0. And so we're just looking for, we're looking again at the sign, what the output is. So if it's below the x-axis, it's negative, and if it's above the x-axis, it's positive. So hope that helps.